4.2 is all about slope and rate of change. And when you hear the word slope, or at least when I hear the word slope, I think about skiing. I think about the slopes, or I think about the angle at which someone is skateboarding or jumping up on a skateboard with. And that is what slope is. Slope is the rate of change, or you can think about it in how the angle is changing or the pathway is changing. So a rate of change is a ratio that compares the horizontal change and the vertical change. It compares the change in the dependent variable to the change in the independent variable. And remember that dependent variable is our y and the independent variable is our x. And when that change is constant, we call it slope. So we use the letter m to represent slope. A couple of ways that we express it. We talk about it as the rise over the run. I was always told that you have to go up or down in the elevator before you get out and go left or right. So that's why rise is on top. You're going up and down in the elevator, and once you get out, you're going left or right. That's on the bottom. Or the change in y over the change in x. And this is the formula for slope. And this is true when you have some point, x1, y1, and some other point, x2, y2. So again, the rise is the up-down. It's the difference in the y values. The run is the difference in the x values, and the slope is the rise over the run. So looking at this little graphic in the middle, we have a positive slope. If we drew a guy on the right, on the far left, and left to right, he's walking upward, he's going uphill, and we in America read left to right. So yes, you could read the opposite the other way and he'd be going down, but look at your graph from left to right. So here, if I drew my guy up here, he would be going downward from left to right. On a horizontal line, the guy would, or the person would not be rising at all, not rising or falling, but that person could stand on that line. So it could be moving left and right. If I was walking across the room right now, even if I'm not going up and down, I'm still walking. That has a slope of 0. I'm not changing the slope or the rise or the run. However, if I tried to stand on this vertical line over here, I'm not going to be able to stand. I'm going to fall. That is called an undefined slope. So vertical lines have an undefined slope. So now that we've talked about what slope is, what it looks like if it's positive, negative, 0, or undefined, let's actually formalize how do I find the slope? So how do we find the slope if we're given a graph? So again, think about this as if I have a person here and he's standing at this left-hand point. First of all, I can tell right away that he would be going uphill. So I should have a positive slope. To find that slope, I want to figure out how this graph is changing from the point on the left to the point on the right. So I want to find the rise. So my slope is the rise over the run. So I want to figure out, I'm just going to count. I'm actually going to count on the graph. What is the rise? What is the run? So the rise, it's going up 1, 2, 3, 4. The run, it's going over 1, 2, 3, 4, 5, 6, 7. So my slope, or my m value, would be 4 over 7. Remember that we always simplify fractions. So if this was 4 over 8, you would be expected to simplify that to be 1/2. But 4 over 7 does not simplify, so this is as far as you have to go. So from a graph, you are counting the rise over the run from left to right, from the left point to the right point. If you are given 2 points, you're going to use the slope formula. And just note, you could in fact graph these 2 points, just like it is graphed on the example before. You could graph those 2 points. You could count the rise and count the run. I know that for me personally, unless I have graph paper, when I graph, it is not accurate enough for me to be able to count. So I would rather use the formula. Plus, I just don't like to graph if I don't have to. But you are more than welcome to graph it if you would like to. This formula says that I need to have 2 points. So I'm going to relabel my first point as x1, y1. And I'm going to relabel my second point as x2, y2. So according to this formula, my slope is y2, which is my second y, -1, minus y1, well, the first y is 5, over or divided by x2, which my second x is 8, minus my first x, which is 2. So this is going to give me -6 over +6. So my slope on this example is -1. So it doesn't matter which point you choose to be your first point or your second point. It does matter that you are consistent in using the same point as your first point and the same point as your second point. So let's practice this a little bit more. Some things I want to let you know, some common errors, some things to watch out for. Remember that if you are subtracting a negative number, 2 minus -5, that this becomes addition. So that's one place that a lot of people get tricked on these slope problems, is if you have a subtracting a negative number, that becomes addition. The second thing, watch out for vertical or horizontal lines, and that actually ties to this next part. Be careful of when you have a slope of 0 over a number, that would mean that the slope is 0, versus a number over 0, that would mean that the slope is undefined. You are allowed to divide a number by 0. You are not allowed to divide 0 by a number. So this part, I'm going to put a little red cloud around it, is incredibly important, and it's one of the places that people get confused the most in this section. You can have 0 in the top, that would just mean that your slope is 0. You can't have 0 in the bottom, that would mean that your slope is undefined. And then lastly, as I was just saying, make sure that you're paying attention to your x1, y1, that you're being consistent with which is your first point and which is your second point. So let's start with the graphing problems. Why don't you go ahead and pause the video and work through numbers 1 and 3, identifying the rise over the run, because your slope is rise over run. Remember that you start at the left point, so here I'm going down 1, 2, 3, 4. And if I'm going down 4, that means that my y value is negative. I'm decreasing by 4. And I am running 1, 2, 3, 4, 5, 6. So my slope, my rise over my run, is going to be -4 over 6. And remember to always simplify your fractions. All right, number 3, we're going to come back to number 2. Number 3, and again, you can see this guy, he would be going downhill. That's why my slope should be negative. If I drew a person here, this person is allowed to stand on this line. He would not fall to his death. So this slope is going to be 0. But if you want to think about that in terms of rise over run, the rise is 0. The run, which it doesn't really matter, but going from -8 to 4 to +4, the run is 12, but 0 over 12 is still just 0. So my slope is going to be 0. If it was a vertical line, my slope would be undefined, and that would look like this person not being able to stand on that nice little line. So we're happy he's not falling. He's just standing on the line. Okay, for 2, 4, 5, and 6, we have ordered pairs, and we can just use the slope formula y2 minus y1 over x2 minus x1. So I'm going to determine that this first point is x1, y1, and this second point is x2, y2. So my slope is going to be, and I'm going to set up in black the part that should always be there, y2 is -2, minus y1 is also -2. Notice that black negative in the middle is because that's a part of the formula, -2 minus -2. And then in the denominator, my x2 is 7 and my x1 is -2. Remember, when we have minus and negative, this is going to become addition. This is going to become addition. -2 plus 2 is 0. Doesn't even matter what's in the bottom, but 7 plus 2 is 9, so our slope is going to be 0. Number 4, I'm going to define this to be x1, y1. I'm going to call this point x2, y2. So my slope is equal to y2, which is 4, minus y1, which is 0, over x2, which is 0, minus x1, which is 0. This is going to give me 4 over 0. This is not okay. I cannot divide 4 by 0. So my answer is not that the slope is 4 over 0. My answer is that the slope is undefined. What that means is we would have a vertical line, and this sad little stick figure would be falling, and we would be so sad. Number 5, you have a bunch of ordered pairs. If you are given more than 2 ordered pairs, you may pick any 2 ordered pairs that you want. And I think on the worked out solutions of these notes, I actually did this multiple times so that you could see that you're going to get the same slope value. So what I'm going to do is I like to use 0. 0 is one of my favorite numbers because it makes things go away. So I'm going to use the point 0, 1. I'm going to call that my x1, y1. And I'm going to use the point -1, 1, -1. That's going to be my x2, y2. So my slope would be y2, which is -1, minus y1, which is 1, over x2, which is 1, minus x1, which is 0. So this is going to give me -2 over 1. So the slope is going to be equal to -2. Just for kicks and giggles, and because I want you to see it doesn't matter which 2 points you pick, let's pick these 2 points. So if I did 0, if I did my second y 1 minus 3 over 0 minus -1, this would give me -2 in the numerator, +1 in the denominator, and I would get the exact same slope. This is not a special case. This is not unique. What we're saying is that the slope everywhere along this line is the same, and that is in fact what makes it a line, is that it has the same slope between any 2 points. So I could keep going and showing you more, but I think showing you 2 is going to give you enough to understand why that slope is the same. All right, very last question, and I know it instantly looks scary because of all of these fractions, but let's just plug everything in and set it up and work through it one step at a time. So y2, 2 divided by 5, y1, 7 divided by 5, x2, 1/4, x1, 3/4. The nice thing here is we have common denominators, so if I simplify the top 2 minus 7, since the denominator is the same, I can combine the numerators. 2 minus 7 is -5. So this is -5 divided by 5 is -1. So the whole numerator, even though it was this scary looking fraction, the whole numerator is just -1. Now let's look at the denominator, and I'm going to write this old school division symbol because I just feel like I'm running out of space here. 1/4 minus 3/4 is going to be -2/4, which is the same thing as -1/2. And if you remember from working with fractions, when you're dividing a fraction, you can change it to multiplication by changing the second fraction. So this is going to become multiplication because I'm going to take the reciprocal of the second fraction. -1 times -2, is going to give me a slope of 2. So the key features of this section of notes. What is slope? Slope is the rate of change. It's the rise over the run. To find that from a graph, you can literally work left to right from one ordered pair to the next and count the rise. That goes on the top. Count the run. That goes on the bottom, and simplify your fraction. If you are given ordered pairs, label one of them x1, y1, and the other one x2, y2, and then use that formula, y2 minus y1 over x2 minus x1, to find your slope that way. Be careful, watch out for subtracting negative numbers, watch out for vertical and horizontal lines, and make sure you're consistent with your x1 and y1 values. Looking forward to supporting you in class. Thanks for listening.